In this session, we will focus on understanding the basics of Venn diagram related minima maxima problems. To be able to understand that, let's start with basics of Venn diagrams. So let's say we have only one Venn diagram or only one circle Venn diagram. How many regions are there? There is region 1 and there is region 2. What if there are two circles in a Venn diagram? How many regions are formed? This is region 1, which is exclusively belonging to circle 1. This is region 2, which is exclusively belonging to circle 2. This is region 3, which is belonging to common to both the circles, and this is region 4, which is outside both the circles. Here there are two regions, here there are four regions. Now let's focus on three circle Venn diagram. When there are three circles that have overlaps, how many regions are there? There are 8 regions. Region 1, 2, 3 are exclusive regions belonging to circle 1, circle 2, circle 3 respectively. This is region 4, this is region 5, this is region 6, which belong to just exactly two circles. First two circle common region is 4, just first two circle. Just first second and third circle common is 5th region. Just third and first circle common region is 6th region. Now what about this 7th region? This 7th region is common to all three circles, and this 8th region is not common to any of the regions. It's completely outside all three circles. So I can see that there are 8 regions when three Venn diagrams are three circles are involved in a Venn diagram. So the pattern keeps going forward. Like when there is one circle, the number of regions that are formed are 2. When there are two circles, the number of regions that are formed are 4. When there are 3 circles, the number of regions that are formed are 8. When there are 4 circles, the number of regions that are formed are 16. The pattern keeps on going. Why is it in 2 powers? Because let's say you take a 3 circle Venn diagram. Now if I take a region, I can ask 3 questions. Does this region belong to circle 1 or not? It may be inside, it may be outside. So there are 2 answers that I may get from here. I can ask a second question. Does this region belong to circle 2? Is it inside circle 2? The answer may be yes or no. So there are 2 variations here. And similarly, I may ask a third question also. Does this particular region belong to circle 3? The answer may be yes or the answer may be no. So there are 2 answers here. So in each of this question, there are 2 variations that are getting built. So overall 2 into 2 into 2, I can have 8 different answers to my question, starting from yes, yes, yes. My answer may be yes, yes, yes to all these questions, or yes, yes, no, yes to first 2 questions, no to second question, similarly third question, and similarly I can have no, no, no to none of all the 3 questions. And correspondingly there will be one particular region mapping to one of this particular answer. For example, if somebody says my region belongs to yes circle 1, yes circle 2, yes circle 3, which means this is the region which is present in all 3 circles. This is this internal region. When somebody says no, my region does not belong to any of the 3 circles, then that region is corresponding to this region number 8, which is outside all 3 circles. Now what if somebody says my circle belongs to first circle, my region belongs to first circle, my region belongs to second circle, but it does not belong to the third circle. So we are speaking about this 4th region. It belongs to first circle, yes, it belongs to second circle, yes, but it is outside the third circle. Therefore we will have 8 possible answers to these questions. 2 variations for first question, 2 variations for second question, 2 variations for third questions. So overall there will be 8 possible answers, and depending upon the answers, each of these 8 possible answers will have one corresponding region, and this pattern keeps going further for n number of circles also. So now that we know that for a 3 circle Venn diagram, there will be 3 circles which are overlapping on top of each other, and there will be 8 regions. Now let's call the first circle as X, second circle as Y, and third circle as Z. Now let's try to write down the number of people in each of the 8 regions. Let's assume that there are A people in first region, B people in second region, C number of people in third region, D number of people in fourth region, E number of people in fifth region, F number of people in sixth region, G number of people in seventh region where all 3 circles are overlapping, and H number of people in the outside region which is not belonging to any of the circles. Now let's try to answer some questions. How many people belong to just X circle? I mean not just X circle, X circle. How many people belong to X circle? A plus D plus G plus F. This is the number of people who belong to X circle. Suppose if the question was like how many people belongs to only X, then the answer would have been A. Only X or just X, then the answer would have been A number of people belong to just X. People who are only inside a first circle but not inside any of the other circles will be A. But here the question is how many people belong to X circle. So all the people who are inside X circle can be taken. So A number of people plus D number of people plus F number of people plus G number of people. Similarly, how many people belong to Y circle? B number of people plus D number of people plus E number of people plus G number of people. How many people belong to Z circle? It is C plus E plus F plus G. How many people belong to X or Y? When I say X or Y, what it means is people can belong to only X, people belong to only Y, or people belonging to X and Y overlap. So it's something like this. People may be inside X circle, people may be inside Y circle. Consider all these people. So this is what you will call as X or Y, or you can call it as X union Y. X union Y, if a region belongs to X region, if a region belongs to Y region, if any of these 2 conditions get satisfied, then we can go ahead and say it belongs to X union Y region. So any one condition, if it gets satisfied, it's more than enough. It may be inside X or it may be inside Y. Any one of these conditions gets satisfied, we can go ahead and say, okay, this particular region will belong to X union Y or X or function of Y. So how many people are here? Number of people would be A number of people plus B number of people plus D number of people plus E number of people plus F number of people plus G number of people. Similarly, what about Y union Z? People who can belong to either Y circle, that condition could be satisfied, or people belonging to Z circle. Any one of these conditions, if it is getting satisfied, it is more than sufficient. Both the condition gets satisfied, it is even good. For example, B and D, first condition is satisfied, they belong to Y circle. C and F, second condition is satisfied, they belong to Z circle. E and G, these people satisfy both the conditions. Therefore, these 6 number of peoples, C plus F plus B plus D plus E plus G, all these people will belong to Y union Z region. Now what about X union Z region? As guessed, people belonging to X circle, either that condition has to be satisfied, or people belonging to Z circle, that condition has to be satisfied, or people belonging to overlap of XZ, that condition has to be satisfied. So here the answer would be A number of people plus C number of people plus D plus E plus F number of people plus G number of people. What about X union Y union Z? Which means people belonging to X condition should be satisfied, or people belonging to Y condition should be satisfied, or people belonging to Z condition should be satisfied, or more than one of these conditions can be satisfied. Or in other words, people should belong to at least one of the circles, or people should be inside the circles, any one of the circles. So the answer is A, B, C, D, E, F, G. All these people, all these number of peoples would belong to X union Y union Z region. Now what about people belonging to X and Y region? X and Y region means it's a AND condition, which means both the conditions should be satisfied simultaneously. People should be inside X circle and people should be inside Y circle. So you can call it as X and Y, or you can call it as X intersection of Y. So people should belong to the overlapping region of X circle and Y circle. These two circles are getting overlapped, right? In that intersection region, how many people are there? Only D number of people and G number of people are present. What about Y and Z? Y and Z is as good as saying Y intersection of Z, or Y circle and Z circle overlapping region, how many people are present? E number of people plus G number of people are present. Similarly, X and Z would be X intersection of Z or X overlapping Z region. X circle and Z circle overlapping region. How many people are there? F number of people plus G number of people. Now to the final question, how many people belong to X and Y and Z region? People who belong to X circle as well as Y circle as well as Z circle. It is X intersection Y intersection Z, just G number of people. The common overlap of all three circles, the innermost region, right? Innermost region, that G, that number of people would be the answer for how many people belong to X intersection Y intersection Z region. Now we will focus on people who belong to exactly one region, or exactly two regions, or exactly three regions. Okay. Now if you focus here, what are these green regions? Green regions are the regions which belong to exactly one circle. For example, if you look at A region, the X only region which has A number of people, that is belonging to only X circle. Similarly, there is a second region which belongs only to Y circle where there are a B number of people. Similarly, there is a third region which belongs to only Z circle where there are C number of people. So when the question asks how many people belong to exactly one circle, exactly one overlapping regions, people who are speaking exactly one language, people who are drinking exactly one drinks out of these three, then the answer is A number of people plus B number of people plus C number of people. Now if you focus on the blue regions are part of exactly two circles. X and Y overlapping, if you look at it, how many number of people are there who are part of only X circle and Y circle? D. Sir, why are you not including G? The reason G is not included is G is not a part of two circle overlapping region. G is a part of three circle overlapping region. The pink color region G is a part of all three circles, X circle, Y circle and Z circle overlap to have this region G. So G is not a part of exactly two overlapping regions. G is a part of three overlapping regions. Then what is a part of two overlapping regions? Exactly two overlapping regions. Just that region which are marked by D, E and F number of people. No, those three regions are the regions which are overlapped with exactly two circles. Just X and Y overlapping circles. If you look at region which is having just X circle and Y circle overlapped, then that is the region marked by D letter. If you look at a region which is overlapped by just Y and Z circle but not by X circle, then that has to be the region which is marked by letter E. Similarly, X circle and Z circle alone should overlap. Y circle should not overlap. Then that region is marked by F. So if the question is like how many people belong to exactly one circle, how many people belong to exactly one overlapping region, how many people drink exactly one drink, how many people speak exactly one language, the answer is A plus B plus C. How many people belong to two regions, exactly two regions, how many people belong to exactly two overlapping regions, how many people drink exactly two drinks out of the three drinks, how many people speak exactly two languages out of those three languages, then the answer for that question is D number of people plus E number of people plus F number of people. Now if the question is how many people belong to all three circles, all three circle overlapping region, how many people speak all three languages, how many people drink all three drinks, the answer is G number of people. So exactly 1 overlap is A plus B plus C, exactly 2 overlap is D plus E plus F, exactly 3 overlap is G. What about exactly 0 circle region which is inside none of the circles, 0 circles, that region is H number of people. This is exactly 1 overlapping, exactly 2 overlapping and exactly 3 overlapping. Now similar to this, there are something called at least 1 overlap, at least 2 overlapping and at least 3 overlapping region. People who are speaking at least 1 languages, people who are speaking at least 2 languages, people who are speaking at least 3 languages. Now people who belong to at least 1 circle, people who belong to at least 2 circles, people who belong to at least 3 circles. Now let's see how many people belong to at least 1 circle region. At least 1 circle or at least 1 overlapping region means they should belong to at least any of the circles, or they should belong to either X circle or Y circle or Z circle. This is nothing but X union Y union Z, which we saw some time back. So A region, B region, C region, D, E, F, G, these 7 regions will be part of at least 1 overlapping region. In other words, exactly 1 overlap plus exactly 2 overlap plus exactly 3 overlap. This will be equal to our at least 1 overlapping region. Or people who speak at least 1 language is nothing but people who speak exactly 1 language plus people who speak exactly 2 languages plus people who speak exactly 3 languages. Now moving on to the second diagram in the page, people who belong to at least 2 overlapping regions, people who belong to at least 2 circles. This will be equal to people who belong to exactly 2 circles plus exactly 3 circles. Or in other words, people who speak at least 2 languages will be equal to people who speak exactly 2 languages plus exactly 3 languages. Exactly 2 languages would be D, E, F people, and exactly 3 language would be G. So exactly 2 plus exactly 3 would be D plus E plus F plus G. This would be at least 2 overlapping regions. Now similarly, people who belong to at least 3 overlapping region, in this case luckily is same as exactly 3, because if there are 3 Venn diagrams, 3 circles, maximum there may be 3 overlapping regions only. So at least 3 is also same as exactly 3 in this case. Therefore at least 3 overlapping region will be equal to G, which is also equal to exactly 3 overlapping regions. So till now what we have seen? We have seen exactly 1 overlapping, 2 overlapping, 3 overlapping, 0 overlapping regions. We have seen at least 1 overlapping, at least 2 overlapping, at least 3 overlapping regions. Why have we not seen at least 0 overlapping regions? Because at least 0 overlapping regions means all the region including H. At least 0 overlapping regions means at least 0 circle means exactly 0 plus exactly 1 plus exactly 2 plus exactly 3. It's entire regions at all 8 regions. So similar to this at least, there is something called at most. People who are speaking at least 1 region, 1 language means people who are speaking minimum 1 language, which means people who are speaking 1 language plus 2 language plus 3 language. Now similar to this, there is something called people speaking at most 1 language. People who are speaking at most 1 language means people should speak maximum 1 language, or people should belong to maximum 1 circle. So they can either belong to maximum 1 circle or they can belong to 0 circle. They can belong to 0 circle or 1 circle. At most 1 means maximum 1 circle region. This will constitute of exactly 0 circle region and exactly 1 circle region. People who speak exactly 0 language plus people who speak exactly 1 language. This is people speaking at most 1 language or maximum 1 language. So this is nothing but H region, which is exactly 0 language speaking people, and A plus B plus C, which is people speaking exactly 1 language. Depending upon the questions, whether it is speaking about exactly one language or at least one language or at most one language, the regions may vary. Now that we've seen the basic terminologies, now let's see what are the different methods that we can use to solve minimum maximum problems. So there are at least 4 or 5 different methods to solve. One is all regions are positive method. Another one is a light and filter method. Another one is a students and chocolates method. Another one or two methods would be equation based method. Now let's focus on these methods one by one. The first method that we'll be looking at is all regions are positive method. Let's start with a small example problem. Let's say there's a group of people. Out of those people, 60% of the people drink tea and 70% of the people drink coffee. Total number of people is 100%. People who are drinking tea or people who are inside tea circle is 60%. People who drink coffee or people who are inside the coffee circle is 70%. Now we have 6 questions that we want to go and answer. Minimum percentage of people drinking either tea or coffee, maximum percentage of people drinking either tea or coffee, minimum percentage of people drinking both tea and coffee, maximum percentage of people drinking both tea and coffee, minimum percentage of people drinking either tea or coffee but not both, maximum percentage of people drinking either tea or coffee but not both. To be able to solve these kinds of questions, let's do one thing. Let's start with a single region. Let's take the number of people in one region as x. You can take any region as x, but it would be easier if you take the tea coffee overlapping region as x. Now if I take this region has x percentage of people, now what can I say about T only region? We know that the entire T circle is 60%. The number of people who are inside the entire T circle is 60%, out of which x percentage is within this overlapping region. Therefore, remaining 60 minus x will be inside T only region. Now similarly, what is the number of people inside coffee only region? Total coffee circle has 70% of people, out of which x percentage is inside the overlapping region. So remaining people who are inside coffee only region is 70 minus x. Now that we have 3 regions, we know that the sum of these 3 regions will be, sum of 4 regions will be equal to 100%. These 3 regions plus the outside region should be equal to 100%. If I use that, the outside region, let me take it as y. I know 60 minus x plus 70 minus x plus y should be equal to 100%. Using that, what I get is my x minus, I get my y is nothing but x minus 30. Now that I have got all these 4 regions in terms of a single variable x. Now, one thing that I should be very much aware of is all my regions are positive. I can only have positive number of people or minimum was 0 number of people. I cannot have negative number of people in any regions. So this is a condition that I am going to use in all the 4 regions. Now let's look at region number 1. Region number 1, number of people is 60 minus x. Now this has to be positive. 60 minus x should be greater than or equal to 0, or x should be less than or equal to 60. Similarly, if I apply this condition to all 4 regions, starting from second region, my second region has to be positive, has to be greater than or equal to 0, which is x greater than or equal to 0. My third region, 70 minus x, has to be greater than or equal to 0, or in other words, x is less than or equal to 70. Now similarly, my fourth region also has to be positive, which means x minus 30 is greater than or equal to 0. Now x is greater than or equal to 30 is the condition. What happens if my x does not follow any of these 4 conditions? My x has to follow all 4 conditions, because all 4 regions should be positive. None of the regions can be negative. What happens if x is not following any of the conditions? For example, what happens if I take x as, let's say, 80? If I take x as 80, there is no problem with the second region or the fourth region. Second region x is 80, positive. Last region x is 80, 50, that is positive now. But the first region and third regions will be negative regions. 60 minus 80 will become negative. How can there be negative number of people drinking tea only? It's not possible. Therefore, the only values my x can take are the values which satisfy all these four conditions. X should be less than or equal to 60, x should be greater than or equal to 0, x should be less than or equal to 70, x should be greater than or equal to 30. But it's not necessarily four conditions, just two conditions are the pressing conditions. For example, if you look at the first condition and third condition, first condition says x should be less than 60. If you take this itself, automatically the third condition x less than or equal to 70 will get satisfied. Because if a number is less than or equal to 60, it will also be less than or equal to 70. Therefore, automatically the third condition also gets satisfied. So we don't have to tell all four conditions separately. If I just tell my first condition, it is as good as saying my third condition. Because if a number is less than or equal to 60, it's for example 50, 40, 30. If a particular value of x satisfies the first condition, automatically by default it will satisfy the third condition also. So third condition is a redundant condition when first condition is already there. Similarly, compare the second condition and the fourth conditions. Second condition says x has to be greater than or equal to 0. Fourth condition says x has to be greater than or equal to 30. Now out of these two conditions, one condition is redundant, which is that the second condition is redundant, which is not required. Because if x is greater than or equal to 30, fourth condition if it is satisfied, automatically the second condition will be satisfied, which is x has to be greater than 0. Only if x is greater than 0 can it be greater than 30. So the essential conditions that we need to take is, even though four conditions are given, the second condition is redundant when fourth condition is given. Redundant means not needed, something additional, something unnecessary, because already fourth condition is given, x is greater than or equal to 30, x is greater than or equal to 0 condition is not needed. Similarly, first condition is the most pressing condition compared to the first condition, third condition is redundant. So let's only focus on the first condition and the fourth condition, that itself will satisfy all four conditions. So x has to be greater than or equal to 30 and x has to be less than or equal to 60. So the minimum value that x can take is 30 and the maximum value that x can take is 60. Now that we have established this part, now let's go to all these 6 questions one by one. Now let's focus on the first and second questions. First and second questions are focusing on the number of people who are drinking either tea or coffee. That is, people who are belonging to either tea circle or coffee circle. So here, any one of the conditions satisfies, that is the region that we can go and take. So we are looking at 3 regions: 60 minus x region, and 70 minus x region. So when we add these 3 regions, what we have here is 60 minus x plus 70 minus x. This is 130 minus x. This is tea region or coffee region, which means people who belong to either tea circle or coffee circle. This is tea or coffee. Mathematically, we can say this is tea union coffee. Now, I need to find what is the minimum percentage of people who drink either tea or coffee. Minimum percentage of people who belong to these 3 regions. So what is the minimum most value of 130 minus x and what is the maximum value of 130 minus x? To find what is minimum value of 130 minus x has to be maximum. Just now in previous page we saw that x can range from anywhere from 30 to 60, not lesser than 30, not more than 60. So maximum value for x is 60. That if I use here, my 130 minus x becomes 130 minus 60, which is 70. That is the minimum most value of tea union coffee. Now, if I want to find what is the maximum most value for tea union coffee, that will occur at x equals to minimum most value. Where does x take its minimum most value? X's minimum most value is at 30. We just saw it in the previous page. So if I substitute x equal to 30, the minimum most value of x in this particular equation, 130 minus x becomes 130 minus 30, which is 100. So minimum most value of tea union coffee is 70. Maximum most value of tea union coffee is 100. In other words, minimum percentage of people who are drinking either tea or coffee is 70. Maximum percentage of people drinking either tea or coffee is 100. The first 2 questions we have done. Now the third and fourth questions. Third and fourth questions are relatively easy because what they are asking is what is the minimum percentage of people drinking both tea and coffee, which means people belonging to both tea circle and the coffee circle, which is the overlapping region. And the overlapping region is nothing but x, and we know the minimum value of x is 30 and maximum value of x is 60. So minimum percentage of people drinking both tea and coffee is 30, maximum percentage of people drinking both tea and coffee is 60. So the second set of questions, third and fourth, are relatively easier. Now the last set of questions, what is the minimum percentage of people drinking either tea or coffee but not both? Either tea or coffee means three regions, 60 minus x, x and 70 minus x. But they are saying but not both the regions. So from these three regions I have to remove the middle overlapping region because they don't want both overlapping regions. So the regions that we are looking for is 60 minus x and 70 minus x, that's all. So if I add 60 minus x and 70 minus x, this two regions will become 130 minus 2x. This is exactly one overlapping region. We saw some time back, right? Exactly one overlapping region. People who are belonging to only tea region and people belonging to only coffee region. People who are belonging to only tea region is 60 minus x. People who are belonging to only coffee region is 70 minus x. So these are the people that we are looking at. So the total is 130 minus 2x. What is the minimum value of this particular region, or what is the maximum value of these particular region? Minimum value for 130 minus 2x will occur when x is as maximum as possible, and we know the maximum value of x is 60. So if I substitute x is equal to 60 in this expression 130 minus 2x, I'll get 130 minus 2 into 60, which is 130 minus 120, which is 10. So the minimum most value for these only tea, only coffee, exactly one region would be 10. Now what about the maximum maximum value that this region can take, the first region and the third region, only tea region and only coffee region? 130 minus 2x, what is the maximum value that it can take? If it has to be maximum, my x has to be as minimum as possible. Minimum value for x is 30. So if I substitute x equal to 30, 130 minus 2x becomes 130 minus 60, which is nothing but 70. So the answer for fifth and sixth question would be 10% and 70%. Minimum percentage of people drinking either tea or coffee but not both would be 10%. Maximum percentage of people drinking either tea or coffee but not both would be 70%. Now this problem we've solved it using the first method, which is all regions are positive method. Using that we identify what is the maximum value that any of my variable x can take and what is the minimum value that variable can take, and using that one variable, because I've expressed my all regions using just single variable, and therefore it is easy for me to understand each region what is the minimum value and what is the maximum value that they can take. So this way I can go and identify minimum and maximum of any region or any combinations of regions that is asked in the question. This is first method that we've seen. Now let's move on to the second method, which is light and filter method. So any problem that can be represented using a Venn diagram method can also be represented using a light and filter method. What is light and filter method? Okay, let's assume there are light rays coming from left side of this particular page to right side, and these light rays can go through this region from 0% to 100%. And what I have kept is I have placed two filters. One is a red filter which is occupying 70% of the entire region. Another one is a blue filter which is occupying 60% of this entire region. 0 to 100% among that region, 60% is occupied by blue region and 70% is occupied by this red region. Now, why am I saying that this particular light and filter method is an equivalent method to this Venn diagram method? Let's look at Venn diagram and see how many regions we are having. How many regions do we have in this Venn diagram? We have 4 regions. Yeah. So region 1 is this outside region, and how many overlaps are there in this outside region? 0 overlaps. No circle is there in this particular region, or this belongs to person who is neither drinking tea nor drinking coffee. This belongs to people who don't drink both these drinks. Now similarly, in our light and filter method also, there are some light rays which are not going through red filter and not going through this blue filter. Which are those light rays? So we have this bottom 10%, right? So this 10% of light rays, they don't go through any of the filters, any of the red filters or blue filters. Now we have this particular region in this Venn diagram problem which belongs to only red color filter. This shaded region belongs to people who are drinking only coffee, not tea, nothing else, only coffee. Similarly, in our above problem also, in the light and filter method also, this is represented by people belonging to the top 30%. Can you see this? This top 30% light rays pass through only one filter, and that is red filter. Now similarly, there is only blue color region or only T region in this Venn diagram method, which is equivalent to this 20% of light rays. So these 20% light rays, what they pass through is they pass through only one filter, which is blue filter. And what happens to people belonging to this both region? They drink both tea and coffee. Similarly, light rays that are in this particular region go through both the red color filter and the blue color filter. So basically, every region in this Venn diagram corresponds to one particular region in the light and Venn diagram, light and filter method. So why is this light and filter method useful? It helps us to identify minima, maxima in certain kinds of problems. Let's go and look at. But before getting into the problems, we should understand that for any unique configuration of Venn diagram, there will be a corresponding equivalent of light and filter diagram. So let's go and show it. Now let's assume the overlap between coffee and tea is, let's say, 50%. And what can I say about tea? The only tea region is remaining 10% and only coffee is remaining 20%. So we have 80% here. So remaining 20% has to be outside. So for this particular configuration, this particular light and filter diagram becomes like this. Now, how many people drink only coffee? Here, light rays that pass through only the red color region is 20% of the light rays. How many people drink only tea? This, which is the light rays passing through only blue color filter, which is 10%. How many people drink both tea and coffee? Corresponds to this particular region, which is from 30 to 80%, which is 50%, which corresponds to light rays passing through both the filters. And how many people drink neither tea nor coffee? In the Venn diagram, it is 20%. In the light and filter method also, it is 20%. So for any number configuration that you are writing in the Venn diagram, there will be an equivalent number configuration in the light and filter method also. So it's exact equivalent of this method. But in some cases, it will help us to visually understand what is the minima and what is the maxima. Say for example, I want to understand what is the maximum overlap that can be there between tea and coffee. What is the maximum number of people who can drink tea and coffee? Here in the lowermost method, I have to use a equation. I have to go and find what is the which region is positive, etc., etc. Whereas in this particular problem, all I need to do is just slide it all the way up, and that's all. Or slide both these filters all the way down. Basically, keep both the filters in same direction. Now you can see that this is the maximum overlap that I can have. Light rays, maximum number of light rays that can pass through both red color and blue color filters are this 60% light rays, 0 to 60% light rays. So these 60% light rays pass through both tea and coffee. So when the question is like how many people can drink maximum tea and coffee, the answer can visually be seen that maximum 60% of light rays can pass through both the filters. So if I want maximum overlap, then I have to keep both these filters on same side. What happens if I want minimum overlap? Then all I need to do is push this filter to as much as possible to the opposite side. Can I push beyond this? No, I've reached the 100%. So this is the minimum overlap I can have. How much ever I push my blue filter to the top side and how much ever I push the red filter to the bottom side, I cannot push them beyond this. So unfortunately I will definitely have this minimum overlap. I cannot reduce it beyond this. So the minimum overlap between tea and coffee is 40 to 70, this 30%. So this is how minima and maxima problems can be solved. Certain kinds of minima and maxima problems can be solved using this light and filter. Can this method be used to solve all kinds of minima maxima problems? Maybe not, but if you have specific Venn diagrams, like specific drinks, what is the maximum overlap between tea and coffee, what is the maximum overlap between tea and milk, what is the minimum overlap between tea and milk and coffee. So these kinds of problems can be solved using this light and filter method. Now it is not just for two cases, even for three cases we'll be able to solve it. Now let's go to the next page and try to solve it for a 3 Venn diagram case. So let's say we have 70% of the people drinking coffee, 60% of the people drinking tea, and 90% of the people drinking milk. So in Venn diagram, it can be represented using the image in the bottom part of the page. In the light and filter method, this is how we can represent. There is a milk filter or a green filter which is occupying 90% of the allowed region, and there is a coffee filter which is red filter occupying 70% of the region, and there is a tea filter or blue filter which is occupying 60% of the region. Now I want what is the maximum overlap that all these three filters can have. Maximum overlap, right? Simple. All I need to do is push all the filters on one side. So the moment I push all the filters either to the top side or I can push them to the bottom side. If I push all the filters to the bottom side, what do I have? I can see that until this first 60% there is all overlap. So this is the maximum overlap, because beyond this a light ray cannot pass through all three filters, because 60% is the maximum length of the T filter, and that is completely occupied. Therefore the remaining 40% of the light rays won't have T filter or the blue color filter to pass through. So this is the maximum overlap of all these three particular drinks. What is the maximum number of people who could have drunk tea, coffee and milk? The answer is 60%. Now for the same problem, what if I ask like what is the minimum number of people who could have drunk tea, coffee and milk? So here we'll have to solve it step by step. In 2 steps we'll be able to solve it. Now let's take coffee and tea overlap and let's try to minimize the overlap. If I want to minimize the overlap, what I need to do is I need to keep these 2 filters as away from each other as possible. Not in the same direction, but I have to keep it in the opposite. I'll push the blue filter as down as possible and the red filter as up as possible. Now how many overlaps, what is the overlap percentage for this, just this blue and red overlap? Blue and red overlap, I have 30%. Can I minimize this beyond this 30%? No, I cannot minimize this beyond this 30%. So minimum 30% people will drink tea and coffee. Now let's take this particular overlapped 30% region and let's try to solve it with milk. Coffee and tea, there may be this number of people, 40% of people who are drinking only coffee. There may be this 30% of people who are drinking only tea. But one thing I know is minimum this 30% of people will be drinking both tea and coffee. Let's take this particular block and let's try to solve it separately with milk. In the next page, what I have is this minimum 30% of people. This is nothing but coffee tea overlap. And let's try to solve it with milk. Now what I need to do is I need to find minimum overlap. So I'll push this coffee tea overlap to the bottom side and this milk overlap to the top side. So if I push this milk overlap to the top side and the coffee tea overlap to the bottom side, even then I can see that there will have to be this minimum 20% overlap. So this 20% overlap is the minimum overlap for milk, tea and coffee. So this is how we can go ahead and solve this minima maxima problems for any selected number of drinks. Like I want like only coffee and tea overlap, what is the maximum or what is the minimum? I want only tea and milk, what is the maximum or what is the minimum people drinking it? So these kinds of problems can be solved using this light and filter method. Now let's look at one more problem. But before we enter into this problem, we should remember that the previous problem allowed us to have certain people not drinking any of the drinks. Um, in this particular previous problem, there were 4 regions and people belong to all 4 regions. There were people who drank both tea and coffee. There were people who drank only coffee but not tea. There were people who drank only tea but not coffee, and there were people who drank none of the drinks, right? However, in this new problem, the situation is slightly different, because there's a statement: in a school of 100 students, each of them play at least one sport among this. So which means out of these 4 sports, people should be playing at least one sport, which means no overlapping region. The number of people is 0. Okay, it is known that exactly 90 people play cricket, 80 people play football, 70 people play hockey, and 60 people play basketball. Out of these 4 sports, I am choosing a particular combination of 3 sports, say cricket, football, and hockey. And for this particular 3 combination, what is the minimum number of students and what is the maximum number of students who could play? So for these kinds of problems, if I try to move with the Venn diagram method, there'll be so many different regions, and I cannot represent using a single variable. So it's better to go ahead with a different method, like a light and filter method. So if I have to draw a light and filter architecture, this is how it would look like. 60% of the people out of 100 people are playing basketball, 70% of the people out of 100% of the people are playing hockey, 80% of the people out of 100% of the people are playing football, and 90% of the people are playing cricket. Now these 4 sports are represented using 4 filters in this light and filter diagram: blue filter, red filter, black filter, and a green filter. Now the question asks, what is the minimum number of students who play cricket, football, and hockey? Green, black, and red. So let's ignore this particular blue color filter, and let's just focus on these 3 filters. Now in this filters, once again we'll have to go step by step. So I want minimum number of people who are playing cricket, football, and hockey. So if I want minimum, I need the filters to be as apart as possible. So let's take hockey filter, and let's push this hockey filter as high as possible, and let's keep the football filter as low as possible. Even if I keep hockey filter to the topmost part, and even if I keep the football filter to the bottommost part, I still have this much overlap. So from 30% to 80%, what is the overlap? I have 50% overlap. I cannot have lesser than 50% overlap between this hockey and football. So this is the minimum most overlap between hockey and football. Now let's take this 50% minimum overlap of hockey and football, and let's try to solve it with cricket once again. So this 50% is minimum hockey and football overlap. Now I want to keep this hockey football overlap and cricket away from each other as possible. So let me push this hockey football overlap to the bottommost possible position, and the cricket just the cricket filter in the topmost position. And the moment I do this, what is the overlap that I have? I can see that how much ever I push these 2 blocks away from each other, there will still be this 10 to 40% overlap that I cannot avoid. So what is the minimum number of students who play cricket, football, and hockey? The answer for this question is 40%. Now to the next question. What is the maximum number of students who play cricket, football, and hockey? This is relatively easy. So if I want maximum overlap, I need to keep all these 3 filters to the same side. Now hockey, I've pushed it to the bottom. Football, I've pushed it to the bottom. Cricket, I've pushed it to the bottom. And now I can see that there are 70% of light rays which are passing through all these 3 filters. So the answer is 70%. However, we need to be a little bit careful here, because in this particular scenario, 0 overlap region is not allowed. What did the question say? The question clearly said that each of them play at least one sport. which means this zero overlapping region cannot be there. It should not exist. So how do I solve this problem? Okay, there's a minor modification that I can make. To make that minor modification, what I'm doing is I'm just cutting my football filter into two parts. That 80% football filter I've cut into 70% filter and a 10% filter, and I'll just push this 10% filter to the topmost part. And now the problem is solved. Every light rays that is passing from left side goes through at least one filter, so that condition is taken into consideration, and still the answer is 70% only. So the answer here, what is the maximum overlap that can be there between hockey, football and cricket, is still 70% only. So this is how we can go ahead and solve problems using light and filter method. So with this we've completed two methods. The first all regions are positive method, and second one is light and filter method. Now we'll start with one more method, which is students and chocolate method, in the next page. Now let's look at a problem like this. There are 100 people, 90 of them are speaking English, 80 of them are speaking French. What is the minimum number of people speaking both the languages and maximum number of people speaking both the languages? So I can solve it using all regions positive method, light and filter method, and also using this third new method that we are going to learn right now. So this all regions positive method, the way we will be doing it is, we will assume that okay, this is English circle, 90 people are there, total 100 people are there, and this is French circle where 80 people are there. If I assume this is X, this is going to be 90 minus X, and this is going to be 80 minus X. I know sum of all the four regions will be equal to 100. Therefore what I can tell is 90 minus X plus 80 minus X plus this outside region is equal to 100. So if I solve for it, I can see that my outside region is nothing but 70, X minus 70. This outside region, what I'll get is X minus 70. So this is X minus 70. So I have all the four regions, and I know that all the four regions will be positive. So this 90 minus X should be greater than or equal to 0, which means my X is less than or equal to 90. This is condition 1. Condition 2 is the middle region, X is greater than or equal to 0. So that itself is as a condition. The next one is the third region, 80 minus X is greater than or equal to 0, which means X is less than or equal to 80. And the fourth region, X minus 70 is greater than or equal to 0, which means X is greater than or equal to 70. So we have two upper bound for X and two lower bound for X. And which is the most pressing upper bound for X? X has to be less than or equal to 80, because if this condition is satisfied, automatically the other condition will get satisfied. Similarly, which is the most pressing lower bound condition? X is greater than or equal to 70, because if X is greater than or equal to 70 condition is satisfied, automatically this condition is satisfied. So it's enough if we take these two conditions. So from this, what we can see here is our X, or the overlap, or the number of people who are speaking both the languages will be between 70 and 80. So the minimum number of people speaking both the languages is 70, and the maximum number of people speaking both the languages is 80. So this is how we can solve this particular problem using the first method, which is all regions positive method. Now the same problem, if we have to solve using light and filter method, what we will do is, like, we will assume that light rays are coming from left side to right side, and this is 0% and this is 100%, and our English filter is 90 region. English filter is 90 region. So this is 90 English. Okay, let's make this a blue filter. And the next filter is French filter, which is 80 filter. Now I want the overlapping region to be as minimum as possible. If I want it to be as minimum as possible, let's keep it in the opposite side. So if the blue filter, if I keep it on the top side, I'll keep the red filter on the bottom side. What is the red filter's length? Which is 80. So people who are speaking French is 80. So this is 80. So I can see that here there is a 20 overlap, and here there is a 10. I mean, here this region is 20, and because out of 100, if 80 is gone, remaining has to be 20, and this region is 10, because out of 100, if blue 90 occupies the above part of this yellow region, the below part of the yellow region is 10. So this region has to be nothing but 70. So I can see that the overlap of this blue and this red region has to be minimum 70, it cannot be lesser than 70. Let's say if you are finding it difficult to understand how the 70 came into picture, let's do in a slightly different method. What we can do is, like, if this is 80, then this has to be 20, and if this is 90, this has to be 10. So the overlap that I am looking at is this green color overlap. So this green color overlap does not include 20 on the top side and 10 on the bottom side, which means how much is this green color overlap? 70. So this is the minimum most overlap that that is possible. Now if you want maximum most overlap, it is very simple. I'll just place my blue filter and the red filter, this 90 units of blue filter and this 80 units of red filter, both on same direction. If I keep both of them in same direction, what I'll have here is I can see that there are 80 overlaps. So I can see that minimum overlap is 70 and maximum overlap is 80. So this is how I can solve this problem using light and filter method. There is a third method that we can solve this problem. We can use to solve this problem, and that is students and chocolates method. So the same problem I am equivalently speaking as, like, let's say 100 people are there, out of which 90 people are speaking English, 80 people are speaking French. What is the minimum people speaking both the languages or maximum people speaking both the languages? Same problem can be equivalently converted into a chocolate problem. Like 100 students are there, out of which 90 students are eating dairy milk, 80 students are eating Kit Kat. What is the minimum people who are eating both the chocolates? And what is the maximum number of people eating both the chocolates? So I can convert this into this problem. And why would the students and chocolate method help me? Because let's say if I have to summarize this, I can see that there are 100 students and amongst them there are 170 chocolates. In how many ways can I mean, not in how many ways, what is the way in which I can give minimum double chocolates? See, here people can either get 0 chocolate or 1 chocolate or 2 chocolate. So people can get either 0 chocolate, none of them, or they can get 1 chocolate, which means they are getting 1 dairy milk, or they are getting 1 Kit Kat. It could be anything. Or they are getting 2 chocolates. If they are getting 2 chocolates, it means they are getting 1 dairy milk and 1 Kit Kat. Now some of you might have a question. Is it possible that somebody can get 2 dairy milks? That is not possible, because in the above problem, can a person speak 2 languages? If I say a person is speaking 2 languages, it means he is speaking 1 French and 1 English language. It does not mean that a person is speaking 2 English languages. Similarly, in this problem, in the bottom problem also, if I say a person is eating 2 chocolates, it means he is eating 1 dairy milk and 1 Kit Kat combination. He cannot eat 2 dairy milk combination. That is not allowed. 2 dairy milk combination is not allowed, because if you look at the above problem, can a person speak 2 English languages? No, he either speaks English or no, that's all. There is no 2 English speaking case and all. Similarly here also, in the bottom case also, he is either eating 1 dairy milk or 0 dairy milk, that's all. He can either eat 1 Kit Kat or 0 Kit Kat, that's all. There is no multiple eating within a same category. There is no multiple language speaking within a French category or within an English category. So this will come in handy in a minute. Now, let's say there are 100 students and 170 chocolates. I want minimum double chocolates. So if I want minimum double chocolates, what I'm going to do is I'm going to distribute 100 chocolates to all the students. First, let me distribute 100 chocolates to all the 100 students. So now what I have done is I have given 1 chocolate to as many people as possible. Now how many chocolates am I left with? 70 chocolates. Now if I give the 70 chocolates to 70 of these students, from these 100 students, I'll have to pick some 70 students and I have to give them 70 chocolates. I cannot minimize the number below 70, because I've already given everybody 1 chocolate. Now I still have 70 chocolates left. There is no other way but I have to give the 70 chocolates to 70 students. So my minimum most double overlapping is 70 chocolates. So what is the maximum most overlap? So maximum most overlap is I have 70 chocolates. Out of 70 chocolates, I need to give to, in how many ways can I give it to, people in pairs? It is tempting to say that, sir, I'll give like 85 into 2, which is equal to 170 chocolates. So for 85 people, let me give, pairs of chocolates. Like I said, if I use this 85 into 2, I'll be making this small mistake. So let's say there are 90 Dairy Milk and 80 Kit Kat. So from this I can see that I would have taken 80 Dairy Milk Kit Kat pairs. After I have taken 80 Dairy Milk Kit Kat pairs, what is left? I am left with 10 Dairy Milk. So the problem in doing this 85 into 2 approaches, I will be left with 10 Dairy Milks, and if I split into 2 people, if I split into 2 chocolates, 5 people are getting Dairy Milk combo. So this is not allowed. So this is a small minor drawback of this particular chocolates and students method, especially with respect to maximum number of people eating both the chocolates. This particular point should be taken into consideration. An alternate approach to look at this is, let's say I have 90 Dairy Milk and 80 Kit Kat. You can look at it as 90 left shoes and 80 right shoes. How many pairs can I make? There may be 10,000 left shoes. It doesn't matter. The right side shoes is I'm only having 80. So I can only make 80 left side right side pairs. Similarly, if I am having 90 Dairy Milk and 80 Kit Kat, how many pairs can I make? I can only make 80 pairs. And what happens to the remaining 10 Dairy Milk? That 10 Dairy Milk will have to go to only one person each. One person will be eating one chocolate. So that will go to one chocolate count only. So the way it will occur is like 80 people will be eating 2 chocolates. One Dairy Milk, one Kit Kat combination. And 10 people will be eating one Dairy Milk each. And what happens to the remaining 10 people? They will not have any chocolates to eat. So this is equivalent to a Venn diagram of Dairy Milk, Kit Kat. The overlap is 80, and here we have 10, here we have 0, and here we have 0. How many people are eating none of the chocolates? 0. No, not 0, this is 10. How many people are eating none of the chocolates? It's 10. How many people are eating only Kit Kat? None. How many people are eating only Dairy Milk? 10. How many people are eating both of the chocolates? It's 80. So this is a small drawback with this chocolates and students method. However, there are cases where this particular method might come in handy. Let's look at one more problem using this particular method. Let's say I have a question where like 60 students are there, out of which 55 have passed maths, 55 have passed English, 50 have passed language, 45 have passed science. Now the question is like, what is the minimum people with minimum number of people who would have passed all 4 subjects, and what is the maximum number of people who could have passed all 4 subjects? This problem I am equivalently taking it into students chocolate method in a way like this. 60 students are there, 55 are eating Dairy Milk, 55 are eating Kit Kat, 50 are eating Milky Bar, 45 are eating 5-star. What is the minimum number of students who ate 4 chocolates, and what is the maximum number of students who ate 4 chocolates? First, let's solve this problem using light and filter method, and then we'll come back to the students chocolates method. Using light and filter method, if I want minimum, let's take 2 subjects at a time. Let's take maths and English at a time. So there are how many students? 60 students. So 0 to 60. And let's take a green filter. What is the length of the green filter? 55 units. And what is the length of the next filter, English filter, which is, let's say, green, when blue is green. So here there are 55 people. So I want minimum overlap. So I'll keep these two lengths, these two filters as away from each other as possible. So here I'll be losing 5, and here I'll be losing 5. So this is the minimum overlap between English and maths. So 55 length maths and 55 length English. They will minimum have 50 overlaps. Now let's take this 50 overlap into the next problem. In the next problem, I'll assume that this 50 overlap. This 50 is what overlap? This 50 is English maths pass overlap. This is minimum number of people who passed English and maths. So that block I'll take it into the next problem, and I'll place them in the bottom side, and I'll place language on the other side. So language, how many people are there? There are 50 people. Now what is the overlap? So here there are totally 0 to 60 people are there, out of which top side if there are 50, bottom side there will be 10. In this particular green color red color filter, in bottom side if there are 50, in top side there will be 10 people. So this top 10 and bottom 10 apart, there will be 40 people, 40 overlap, and this 40 is nothing but English max language minimum overlap. Now let's proceed one more step further. So what is the minimum amount of English max and language overlap? 40. So let's place that 40 here. So this is English max language overlap 40 people out of 0 to 60 people. Now I want to place this signs as away as possible. I want minimum overlap. I'm looking at minimum overlap with this English max and language. So this 45, if I place it here, this is signs. So what is the unavoidable overlap? This is minimum overlap. I cannot escape this. So here I have 50, here I have 20. So out of 60, 15 and 20, 35 is gone. So what is the remaining overlap? Unfortunately, this 25 is something I cannot avoid. So this 25 overlap is minimum overlap of max English, science and language. So this problem, let's look at it in the students and chocolate method. It might be easier. How many chocolates are there? 55 plus 55, 110. 100 plus 50 is 160. 160 plus 45 is 205 chocolates. Out of these 205 chocolates, I need to give these 205 chocolates to how many students? 60 students. And I want to minimize 4 overlap. If I want to minimize 4 overlap, I have to make sure that there is no fourth chocolate for any students. Maximum people can get 3 chocolates only. Beyond that, no student should get, or as minimum student should get fourth chocolate. So let's do one thing. Let's try to deplete all the chocolates by giving 3 chocolates to as many students as possible. So what I'll give is, for 60 students also, even if I give 3 chocolates per students, I would have depleted how many chocolates? 180 chocolates. So there is no other way. I'm left with 25 chocolates which I'll have to give to some students. So these 25 chocolates, if I give to 25 students, these 25 students who already got triple chocolate will now end up with 4 chocolates. So these 25 students would have eaten all 4 chocolates. So now can you see how this students and chocolate method is easy in scenarios like this, where there is minimum number of people eating all 4 chocolates. These kinds of questions, the students and chocolates method might come in very, very handy. Now, final question of this particular method: what is the maximum number of people who ate chocolates and all 4 chocolates? Like I said, we have to find combo. So we have Dairy Milk, Kit Kat, Milky Bar, and 5-star. We have 55 Dairy Milk, 55 Kit Kat, and 50 Milky Bar, and 45 5 stars. So I need to make a combo. It's more like left shoes and right shoes. If I have 70 left shoes and 100 right shoes, how many pairs can I make? It doesn't matter if there are 30 extra right shoes. I can only make 70 pair. Similarly, how many 4 combos can I make? This is the constraint. So I can only make 45, 45, 45, 45. So 45 is the maximum number of students who can eat all 4 chocolates. In light and filter method, it's very simple. All I need to do is just place all the filters on same side. So here I have 55, and here I have another 55, and here I have 50, and finally here I have 45. So this is the maximum light that can pass through all 4 filters. So maximum number of students who ate all 4 chocolates, or maximum number of students who passed all 4 subjects, is 45. So these are some scenarios where this particular method might come in handy. So we've seen 3 methods, and it's not like all 3 methods can be used in all different scenarios. There are scenarios where chocolates and students method might come in very handy. There are scenarios where light and filter method might come in handy, and there are scenarios where the all regions are positive method might come in handy. All regions are positive method is very, very convenient when there are 2 Venn diagrams. More than 2 Venn diagrams, that might get complicated. Light and filter might be useful when you're asking about minimum or maximum of selected subjects. Max English language, for just these three subjects, what is the maximum overlap or minimum overlap? If you select some subjects, and for that selected number of subjects, if you want to find what is the maximum or minimum, light and filter method will be very, very easy. Whereas this chocolates and students method, let's say all overlap, maximum number of all overlap or minimum number of all overlap. In cases like that, this students and chocolates method might be very, very comfortable. Now let's look at the last method, which is an equations based method. To be able to solve this, to be able to understand this method, let's look at a 3 Venn diagram scenario where 100 people are writing a CAT exam. Out of those people, 65 people have passed verbal, 60 people have passed DA, 55 people have passed quants. And these yellow regions, right, they are one overlap region, and these red regions are 2 overlapping region. These green regions are 3 overlapping regions, and this black region or gray region is no overlapping region. Now, what can I say about people who belong to at least one circle? People who belong to at least one circle are A plus B plus C plus D plus E plus F plus G. What can I say about people belonging to at least 2 circles? People who belong to at least one circle is exactly one circle, yellow region, plus exactly 2 circle, that is red region, plus exactly 3 overlapping region, which is green region. Similarly, what are the people who belong to at least 2 regions? At least 2 regions would be exactly 2 region, which is D plus E plus F, plus exactly 3 regions, which is G. What can I say about people who belong to exactly 3 regions? I mean, at least 3 region. At least 3 region is, in this case, nothing but 3 region only. At least 3 regions means minimum 3 regions or more than that. Here 3 regions or more than that is not there, only 3 region is there. Therefore we are speaking about at least 3 region is nothing but G. Here what I can tell is, from this relation, from this expression, I can create a relationship between A1, A2, A3. One thing, every region is positive. Therefore one thing I can tell is A1, if you look at A2 and compare it with A3, A3 is already included in A2. In addition to it, some extra part is only there. Similarly, A2, whatever is there, that is already included in A1, and in addition to it, some extra part is there. So I can create a relation here. What relation I can create is A1 will always be greater than or equal to A2, will always be greater than or equal to A3. This is a relation which will hold true irrespective of what is the number that is given. And A3 will always be greater than or equal to 0% of the people. It cannot be negative, no? Every region has to be positive. And A1 has to be less than or equal to 100%. Of course, A1 is at least one overlap, can be maximum 100% only. 100% of all the people that involved. So this is one beautiful relation. In addition to this relation, there are few more couple of small relations that we are going to learn. Okay. Now, before going further, let's just add these things, what we'll get. Let's say if I add A1 plus A2 plus A3, let's see what we are getting. What we will get is A plus B plus C will be counted one time, plus D plus E plus F will be counted 2 times, plus G will be counted 3 times, right? It is not just A1 plus A2 plus A3 which follows this expression. There is one more thing that will follow this expression. Let's go and see. What is, let's call this circle as X circle, let's call this circle as Y circle, and let's call this circle as Z circle. What is X circle? X circle is nothing but A plus D plus E plus G. What is Y circle? Y circle is B plus D plus F plus G. What is Z circle? Z circle is nothing but C plus E plus F plus G. When I add all these x plus y plus z, what do I get? X plus y plus z. Once again, I am getting my A, B, C added one time. A plus B plus C. And once again, my D, E, F comes two times here. Plus 2 times D plus E plus F plus what happens to my G? G comes 3 times. So plus 3 times G. Can we see that this expression x plus y plus z is exactly same as the expression a1 plus a2 plus a3. If you look at a1 plus a2 plus a3, whatever that expression a plus b plus c plus 2 times d plus e plus f plus 3 times g is exactly what are x plus y plus z also. Or in other words, my second expression is a1 plus a2 plus a3 will always be equal to sum of the three circles values. Okay, we are almost there, just two more relations and we are done with this particular concept. The one more relation that we can look at is, okay, a1 can be maximum what value? 100%, but it cannot be lesser than a2. Similarly, a2 has to be lesser than a1 but definitely greater than a3. Similarly, a3 should be greater than 0% but can be lesser than, should be lesser than a2. In addition to this condition, a1 and a3 will have one more condition to follow. What is a3? A3 is at least 3 overlapping region. In this case, exactly 3 overlapping region. Now, 3 overlapping region has a upper bound. It is similar to that, right leg, left leg shoe question. So, what is the maximum amount of 3 overlapping region that is possible from 65 verbal, 60 DI and 55 pass? 55 quants. 55 is the maximum 3 overlapping region. Even if you look at light and filter method, here you have 65, here you have 60, here you have 55. What is the maximum possible overlap of 3 region? 55. So that is another upper boundary for A3. This A3 has to be, what is the maximum value of A3? A3 maximum value is nothing but minimum of circle X, circle Y and circle Z's value. So this A3 has to be always less than or equal to this particular value. I'll explain this once again in the next page. Let me just complete this expression. There is one more expression similar to A3. A1 also has a lower bound. A1, at least one, I can minimize it as much as possible, but I cannot minimize it beyond the 65, no? So this 65 is nothing but maximum value of my 3 circles. So this A1 can never be lesser than 65, which is nothing but max value of x, y, z. Let me explain this expression once again in the next page so it may be a little bit more clear. So in this particular problem, what we have is at least one region, at least two region, at least three region. The relations is something like this. At least one region will be lesser than 100%. At least two region will be less than or equal to at least one region, and at least three region will be less than or equal to at least two region, and at least three regions lower bound is 0%. Or in other words, A1's lower bound is A2 and higher bound is 100%. A2's higher bound is A1 and lower bound is A3. A3's higher bound is A2 and lower bound is 0%. Not just this, one more thing is also there. Two more things are also there. This A1, it is not just greater than or equal to A2, it is also greater than or equal to one more value. What value? This is greater than or equal to maximum of x, y, z. Similarly, this A3, right, it is less than or equal to A2, not just A2, it is less than or equal to one more value. It is less than or equal to minimum of x, y, z. Okay, that's all. This is all the relation that we need to know, in addition to a1 plus a2 plus a3 equals x plus y plus z. So now if you look at it, this a1 has a upper bound of 100% and two lower bounds. One is a2, another one is maximum of x, y, z. What is x, y, z? The three circles. Similarly, a2 has one upper bound a1 and one lower bound a3, whereas a3 has one lower bound 0% and two upper bound. A3 has to be lesser than a2. In addition to it, a3 has to be lesser than this value, minimum of x, y, z. Then not just this, in addition to this, we also know that a1 plus a2 plus a3 is nothing but summation of x plus y plus z. How can we use this to solve our problems? Let's look at this problem. So here, what is our x value? 65. What is our y value? 60. What is our z value? 55. So what I can tell here is a1 plus a2 plus a3 together equals 180. Now this 180 should be given to a1, a2 and a3 in such a way that none of these conditions violate each other. Okay, and what is the maximum of x, y, z? 65. So a1 is greater than or equal to 65. And what is the minimum value of x, y, z? 55. So this a3 is less than or equal to 55. That's all. This is all the condition that is needed for us to solve any kind of minima maxima problems with respect to two region, at least two region, at least three region, exactly one region, exactly two region kinds of questions. So now let's look at various kinds of questions that may be asked here. Question number 1. What is the maximum value of at least three region or exactly three region? At least three region or exactly three region, because when there are three Venn diagrams, whether you say exactly three region or at least three region, both are same only. What is the maximum value of at least three region? We know that this limit is 55. What is the minimum value of at least three region? That is 0%. So what is the maximum value that G can take? G region can take 55. What is the minimum value that G region can take? 0. This part is clear. Now, not just this A3, even A2 we can go ahead and solve it. So, regarding A2, at least two regions. What is the maximum value of at least two regions? See, in a Venn diagram, there may be zero region, zero overlapping region, one overlapping region, two overlapping region, three overlapping region. Now the question that is asked is, what is the maximum value of at least two region? At least two region means two overlapping region plus three overlapping region. So what is the maximum value that I can give to my A2? The maximum value that I can give to my A2 is in such a way that 100 is lesser than A1, lesser than A2, this is A3, this is 0. Now I need to split my 180 between these numbers. I want to give as much as possible to A2. But whatever I give to A2, I have to give to A1 also. So let's do one thing. Let's give 0 to A3 because the A3 can get as low as possible, no? So out of this 180, I'll give 0 to A3. So remaining how much is there? How many is there? 90 is there. So can I give 100 to this and 80 to this? Not possible, because A1 has to be greater than or equal to A2. So what is the maximum that I can push towards A2? Whatever I give to A2, I have to give to A1 also. So let me equally split to A1 and A2. So 90. So 90 is the maximum value of A2 region. That is two overlapping and three overlapping region. What is the maximum value that both these regions together can take? Both these region can together take 90 at the max, not more than that. Okay. 90 people can 90 people could have passed in at least 2 subjects. Maximum 90 people could have passed in at least 2 subjects, not more than that. Okay, now what if the question is 0, 1, 2, 3? What is the minimum value of this particular region? What is the minimum value of this particular region? At least 2 regions are there, no? That red color region and the green color region. What is the minimum number of people who could belong to this particular region? I want to distribute as minimum people as possible to A2. So if we want to do that, I need to distribute 180 into A, B, A3, A1, A2, such a way that A2 gets as minimum as possible. So what I'm going to do is I'm going to first give as much as possible to A1. What is the maximum possible value that I can give to A1? 100. After I give 100 to A1, how much is remaining? 80 is remaining. That 80, can I give in 0-80 way? No, that is not possible, because here A3 has to be less than or equal to A2, or in other words, A2 should receive at least whatever A3 is receiving. So that remaining 80, I can only give it in 40-40 method. So I can only give it in 40-40 kind of. So the minimum value my at least 2 region can take is 40. So this is how we can go and solve problems related to what is the maximum value of at least 2 overlapping region, what is the minimum value of at least 2 overlapping region, etc, etc. Let's look at some more problems in the next page. Okay. Now let's write down the conditions again. A1, A2, A3. A1 is lesser than 100%, A2 is lesser than A1, and A3 is less than A2 and less than or equal to, and A3 is greater than or equal to 0. Not just this, A3 is also less than or equal to 55 and A1 is greater than or equal to 65. Let's remember these conditions. Now let's focus on what is the maximum value at least one can take, at least one region. I want to give maximum value only, no? I'll give 100 here out of 180. A1 plus A2 plus A3 equals to 180. That we know, right? A1 plus A2 plus A3 equals to 180. So out of this 180, I'll give 100 to A1. And to A2 and A3, I can give as per my convenience. I can give maybe 60-20 or 40-40. No condition is violated. A1 greater than or equal to A2 greater than or equal to A3 condition is satisfied. A1 is greater than or equal to 65 condition is satisfied. A3 is less than or equal to 55 condition is satisfied. Everything is satisfied. So A1 maximum value that A1 can take is 100 only. Okay, what is the minimum value that A1 can take? Minimum value that A1 can take is, it's already given, no? We have a lower bound. So 65. Lesser than 65 or A1 cannot take. So the lowermost value this can take is 65. Now if this takes 65 out of A1 plus A2 plus A3, 180, remaining how many values do we have? 115 values we have. So this has to be, this 115 has to be split accordingly equally between these two. So let's say this can maximum take 55 and remaining 60 is possible. This is one possibility, or I can even go ahead and give 50 here and 65 here. This is also possible. None of the conditions are getting violated. So this way I can go ahead and play around. Only thing that I need to take into consideration is this black conditions to be satisfied. A1 plus A2 plus A3 equals to 180. This 180 I need to distribute to A1, A2, A3 such that these conditions are satisfied. To be noted, this A1, A2, A3 are at least one region, at least 2 region and at least 3 regions respectively. Now some of you might have a question. Sir, what if they ask about exactly 2 regions? I want exactly 2 regions maximum and exactly 2 regions minimum. How can I go ahead and do it? So at exactly 2 region is nothing but at least two region. What is at least two region? D plus E plus F plus G. That exactly two region plus exactly three region. What is at least three region? G. So subtract these two. What do we have? G gets cancelled. D plus E plus F. So if you want exactly two region, it is nothing but at least 2 minus at least 3. Okay. Now if somebody wants to maximize exactly two region or minimize exactly two region, all I need to do is A2 minus A3 difference I have to maximize, or A2 minus A3 difference I have to minimize. Let's focus on one by one. So let's focus on, I want to increase my exactly two region. I want to maximize my exactly two region. So what I need to do is, I need to increase my A2 to as high as possible and A3 to as minimum as possible. Only then my E2, exactly 2, will be very, very high. So how much can I minimize this A3? I can make A3 to 0. How much can I increase A2? A2, so once out of 180, if I've given 0 to A3, remaining 180 is there. That 180, I can't give 180. This is not possible because A2, whatever is there, minimum I have to give the same thing to A1 also. So what is the value that I need to give to A2? I can only give 90 at the max, not more than this. So A2's maximum value is 90. A3's minimum value is 0. So I can see that this 90 minus 0 will be the maximum value that E2 can take. Because A2's maximum value is 90. A3's minimum value is 0. So 90 minus 0 could be the maximum value for exactly 2. What about minimum value for exactly 2? Exactly 2 should be as minimum as possible. Or A2 minus A3 should be as minimum as possible. First of all, this cannot be negative. This has to be as minimum as possible. Let's go and see whether 0 is possible. In one of the scenarios, we saw this could be 100 and the remaining, out of 180, 100 I have distributed here. Remaining 40 and 40 here. Is it possible? Yes, it is possible. No condition is getting violated. A1 greater than or equal to A2. Perfect. A2 greater than or equal to A3. Perfect. A3 greater than or equal to 0. Perfect. A1 is greater than or equal to 65. Perfect. A3 is less than or equal to 55. Perfect. Every condition is getting satisfied. So this is one case. So similarly, many cases where I will have A2, A3 will be A2 and A3 being equal to one another. For example, A2, A3, here it may be 80. So remaining 100 I can split into 50, 50. In this scenario also A2 and A3 are equal. A2 and A3 are equal means at least 2 region and at least 3 region are equal. At least 2 region na D plus E plus F plus G. This is equal to at least 3 region. So if these two values are equal, which means D plus E plus F is equal to 0. So that is the lowermost value that E2 can take. So this is exactly 2 region. So similarly, I can go ahead and solve many similar problems. Now let's go ahead with one more problem. Exactly one region, what is the maximum and what is the minimum value that exactly one region can take? Exactly one region. How will I get exactly one region? Exactly one region is nothing but at least one region minus at least 2 region. Because at least one region is region 1, region 2, region 3. At least 2 region is region 2 and region 3. When I subtract it, what I will get is exactly one region. So my exactly one region I will obtain by subtracting at least one region minus at least 2 region. Now if I want this value to be as high as possible, I want A1 to be as high as possible, then A2 to be as low as possible. What is the maximum value my A1 can take? 100. After giving 100 to A1, what is the lowest I can give to A2? Remaining 80 is there. Out of 180, 100 I have given to A1. So remaining 80, can I give 0 and 80 to this? No, this scenario is not possible because whatever I am giving to A3, minimum that value I have to give to A2. So the only way I can split it is 40 and 40. So this is the maximum value that A1 can take. And in this scenario, when A1 is taking 100, minimum value A2 can take is 40. So this difference is 60. So maximum value for exactly one region is 60. Now similarly, let's go ahead and try to solve what is the minimum value for exactly one region. So if I have to find what is minimum value of exactly one region, if I want this to be minimum, I want this to be as minimal as possible and this to be as maximum as possible. Okay. Now, or in other words, I want their difference to be as low as possible. And we have seen one scenario earlier wherein I'm giving 0 to A3 and I'm giving equal numbers to A1 and A2. In this scenario, what is A1? A1 doesn't have to be as minimum as possible and A2 doesn't have to be as maximum as possible. Their relative difference, if it is as less as possible, that itself is sufficient. A1 doesn't have to be 65 necessarily. Even if you want A1 to be 65, that is also a possible solution. So let's say A1 wants to be 65. Then A2 and A3, I want to increase A2 to as high as possible. Now, if A1 is 65, A2 can grow only until 65, not beyond this, because there is a condition A2 is less than or equal to A1. So maximum it can grow until 65 only. And here remaining 50 can be given to A3. So what is the difference between A1 minus A2? 0. This is one possible solution. Alternate way of looking at this would be, I'll give 90 to A1, 90 to A2 and 0 to A3. So if I give 90 to A1 and 90 to A2 and 0 to A3, is any condition getting violated? Absolutely not. 100 is A1 lesser than 100, less than or equal to 100? Yes. Is A2 less than or equal to A1? Yes. Is A3 less than or equal to A2? Yes. Is A3 greater than or equal to 0? Yes. Is A1 greater than or equal to 65? Yes. Is A3 less than or equal to 55? Yes. So all the conditions are getting satisfied. So using this particular method, we can go ahead and learn at least one maximum minimum, at least two region maximum minimum, at least three region maximum minimum, exactly one region maximum minimum, exactly two regions maximum minimum, exactly three regions maximum minimum. But it's getting too much equation oriented. But if you look at it, there are only very handful of number of relations. A1, A2, A3 ranging between 0 and 100 in this particular order. A1 will be greater than or equal to 65. 65 is nothing but maximum value of the circles. And A3 will be less than or equal to 55, which is nothing but the minimum of value of the circles. And what is A1 plus A2 plus A3? It is nothing but sum of the circles. That's all. These green highlighted regions, if you are comfortable with, you will be able to solve problems using this particular method.